Hello everyone, welcome to the next lecture on the CSR UGC NET Mathematics. Today we will discuss about the PY questions on the ordinary differential equations of all those papers starting from the December 2011 to December 23. Myself Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg, or else simply scan and join my WhatsApp group where we will see various discussions. As you can see on this YouTube channel, you can see the playlist CSR UGC NET, where you can find the PY questions of the integral equations from the year 11 to 23, PY question of the calculus of variation, PYQ questions on the Eigenvalue, LPP, optimization techniques, differential equations, statistics, and many more. All are available in this playlist. You can simply like, share, and join this WhatsApp group. What we will see in this lecture, we will see how you can solve the ordinary differential equations with the help of the shortcut tricks. I will tell you many of the shortcut tricks in this video, so you can watch till the end of this video. We will discuss the 50 plus questions in this video, and you can see within 30 minutes we can cover all these questions. And we will upload the next part, that is again the 50 plus questions from the year June 11 to June 2023 in this second part. So let's start with this video. This is the question related to the December 2020. Now what is the tips for you? Instead of reading the question, whenever there is a question of y dash is y raised to power alpha, where alpha belongs to the 0, 1, then it always has infinite number of solutions. That's a simple tips for you. Whenever, because this is the y dash is y raised to power alpha, if I say, and one more condition is y of b is 0, where this b must belongs to the real number, then it has the infinite number of the solutions. On the other hand, if you have the differential equation y dash of this, where alpha belongs to the 0, 1, and y of b is 0, provided it has a negative number, then it has a unique solution always, and the unique solution is always be the trivial one, that is y is equal to 0. That's a simple tips for you in this question. Now what is that? You have to see 5k over 5k plus 2 is always less than 1. Then what is the meaning of that? And the coefficient is my positive, because this is my positive, so it has the infinite number of the solution is the right answer of this problem. Again, the question is December 12. You can see I can return this number as 60 y raised to power 2 by 5, and the condition is y of 0 is 0. See, this 0 is my b belongs to the real number, and this is belongs to the 0, 1, and this coefficient is my positive. So how many solutions are there? Infinite many solutions. So the right answer is my D is my right answer. Now this, what is that? Whenever there is a differential equations of this kind and the initial condition is my here, then you can easily find the value of the lambda is nothing but my here. What is the L is? If I say, I simply tell you the general condition, this is 0, whenever x lies between 0 to L, y of lower limit and y of upper limit both are 0, then you can say the solution of this is my here, the corresponding eigenvalue is this, and the solution will be a sine n pi by lambda of x. This is my solution and this is my eigens value. So if you compare them, what is that? Limit is my from 0 x to pi, so L is my pi. If I substitute here, what is the value of the lambda is nothing but my n square, and they have the non-trivial solution for what value of the lambda, so that is n square. This is the correct answer of this problem. This is the question number 2017 of the CSR NET. So that's a simple shortcut tricks for you. If they are asking about the solution, then you can substitute here, you will get the right answer. Okay, now this is the Wronskian. Whenever there is a question of the Wronskian, you always start from here, plus py is equal to 0. What is that? If you compare them, py dash plus qy is equal to r, then the solution of the Wronskian will always of this form. So what you can do, what is a p? If you compare, you have to divide by cos. So what is my p? P is nothing but sine by cos is my tan of x. Fine. Now if I substitute here, what is the meaning of that? If I integrate them, this is my minus P of dx. So what is the meaning of that? It's a c e raised to power minus P dx. Now if I say P is my tan of x, what is the answer of this? E raised to power minus integration of tan is minus log of cos x. So the answer is c of cos x. Fine. Now what is that? Wronskian. What is the value of the Wronskian? Is w1, y1, y2, y dash and y2 dash. At the point 0, it is given to you root 2, 1, minus root 2 and 2. So what is the answer of this? Is 3 root 2. So what is that? Wronskian, when x is equal to 0, this c cos of 0 is 1. So c will be my 3 root 2. So I can substitute here. What is the answer of this? 3 root 2 cos x is the right answer. Now you have to find the Wronskian at pi by 4. What is the answer of the pi by 4 is? It is a 1 by root 2. It's a cancel out. So the right answer is my C is the correct answer. Again, this is the Wronskian. So I can start from here. This plus of P x is equal to 0. So here in terms of the t, so we can write as a P of t. So I can written as dw by dt plus P of t is equal to 0. So what is my P? If you divide them, it will be my half. So I can check this value P. So if I see what is the meaning of that w, this plus half of t is equal to 0. So you can see the first derivative is not satisfied. This value, this is satisfied because you can see this value will be P of w, sorry, P of w. So if I say the first derivative is not satisfied because of the half, second one is the derivative is minus c by 2 e raised to power minus t by 2 and it is satisfied me. So the right answer is my here. All are questions of the 40, 42, all are my part B, so only one correct answer. Clearly say that this is not satisfied. E raised to power minus 2t is not satisfied. The right answer is only B. Now the next part is, again you can see this is my u dash is a constant, u raised to power 3 by 4, u of 0 is 0. Again this number is lies between 0 and 1 and this is my real number. B is a real number. So it has infinitely many solutions. So you can see clearly say that u of 0 is 0, infinite many solution, trivial solution is my here. This is also satisfied. Obvious that because u of 0 is condition is satisfied. Again you can see these are the same. If I simply say t minus 1 is say h, so what will happen of this? U of h plus 1 is my 0 and this is h raised to power 4, which is same as that of this. Otherwise you can also think about this like this way. If you take that derivative, what is that? This is t minus 1 3. So I can write this t minus 1 from here. This is u of 3 by 4. I can find the value of t minus 1 from here, u 1 by 4, which is same as that of this. And similarly this is the similar. So all are my correct answer. This is the question related to the part C. This is a question related to the part C, which is related to the step number. Again you can see the first part is y dash is y of half, y of 0 is 0. This number is lies between 0 1. So it has infinitely many solutions. On the second part, the solution is minus y of half, y of 0 is 0. This number is lies between 0 and 1, but because of this negative it has a unique solution and the solution is my this part, that is a 0. The first one has infinite many solution. The first one has an infinite solution. Second one has a unique solution. So second has a multiple solution cancel, second has a unique solution. So the B and C are my correct answers. Now this is not the differential. Now you can see which of the following intersect. A very simple are there. You can integrate them. I can simply take dy over this. So what is the integration of this? So y plus 17 is log of this is my x plus c. So what is that? Y of 0 is 0. So what is that? So y1 0 is equal to 0. So it means c is my log of 17. y2 of 0 is my 1. So c is my log of 18. So what are the answers of this? So I can say y1 plus 17 is e raised to power x into e raised to power c is my 17. For the second case, y2 plus 17 is e raised to power x into 18, which is not possible. You can see on the left hand side are same, right hand side means this is only possible when e raised to power x 0, which is not possible. So it means they are not intersecting each other. So right answer is my A. Okay, next one is December 11. There's only one correct options. F, consider the differential equation y dash 1 plus f square y. Condition is y of 0 is my 1. F is my bounded and continuous. So since there is no more condition given to you, consider any of the function which is bounded as well as continuous, a constant function. F of 0, or you can take f of 1 is a constant function, is bounded as well as continuous. So if I say f is my 0, what will happen? Y dash is y. So what is the solution of this? So what is the solution of this is y is equal to c e raised to power x. Y of 0 is 1. So c is my 1. So what is the answer of this? Y is equal to e raised to power x. So this equation admits a unique solution, correct, and the limit exists, but that's wrong. What is the limit? As x or t approaches 0 of e raised to power t goes to the infinity, which is not finite. First option cancel out. This equation admit two linear independent solution, cancel out because it gives only one solution. This solution admits a bounded solution and the limit does not exist. That's also the wrong answer because e raised to power x is unbounded are there. So this is cancelled out. This solution admits a unique solution, correct. Limit goes to the infinity is the right answer of this. So that's very simple because they are talking about any of the function which is bounded and continuous. You can take as f of 0 is the right answer or f of 1 is there. Okay, next one is which of the following is there. Now here is a word of the fundamental set. What is the meaning of the fundamental set? The fundamental y1, y2 are the fundamental set. It means the first property is y1 and y2 are my continuous. Second property is y1 and y2 are Li. Third one is y1 and y2 has no repeated roots. That's the property of this fundamental uniqueness property of these conditions. Now you can see about that, and between the any two consecutive zeros x1 and x2, so what is given to you? y1 x0, y1 x1 is 0. Okay, fine, that's a very simple answer. What is the meaning of that? If y1 and y2 are, then the Wronskian is my non-zero. Fine. Now we can see that only the one correct option is there. y1 is this, such that of this. That's, I think, first of all this one. What is the meaning of that? From here you can see y1 of x0 is 0. y1 dash of x0 is also 0. What is the meaning of that? x0 has repeated root, but because of the fundamental property it has no repeated root. It has a cancel out. y of x has no zeros in x0 and x4. Fourth property is also be there. y1 and y2 has at least 1 0 in here. So but he said no 0, so it also has a cancel out. Moreover, you can simply take y2 as of this, say q0 again. So clearly says that y0 of x0 is 0. What is the meaning of that? So if I take as a Wronskian y1 y2 y1 dash y2 dash. So what is the answer of this? At the point x0, y1 is 0, y2 is 0, this is unknown, this is non-zero. But whatever, whether it's a 0 or non-zero, the determinant is a 0. So but we need a Wronskian as a non-zero. So it means this property cannot be handled. So this is the only the right answer. How you can verify that? Again, we can check the Wronskian. What is the derivative of this? Derivative is my Q0x, and Q0x naught is a non-zero. So what is the Wronskian? W1 is 0, W2 at x0 is we don't know, W1 of this is a non-zero, and whatever here. So this is my always a non-zero. So right answer is my A. Okay, y is a non-trivial solutions, and which of the following conditions are here? That's a very simple. If you look about this condition, which things come in your mind when you try to solve this? If I just try to convert this equation into here, then we will get easily as a solution. So this solution only when x is equal to 1. So we can choose x such that we can choose the interval such that this and this are zeros. So if I choose minus pi to plus pi, that is a 3.4 to 1. If I take x as a 1, then this equation will be here. So what is the solution of this? C1 cos x, C2 sin x. And what is the condition of the y of pi 0? Y of pi 0 means C sin 0 is 0, so C1 is my 0. So what is the solution of this? C2 sin x. Fine. Now clearly say that what is the my A is minus pi, B is my pi, B is a greater than 0, satisfied. Y is monotonic if this condition satisfied. Minus pi less than 0, satisfied. And y is monotonic from minus pi to plus pi, that's satisfied. It's a monotonic function. Y dash is 0. So what is the y dash of this? So C2 cos x clearly says that y dash of A is by minus pi, which is non-zero because y is a non-trivial solution. So it's a non-zero, so it is cancelled out. It has infinitely many solutions. So how you can check the infinitely many solutions in AB? You can see what is the graph of this. This is a graph of this from minus pi to plus pi. Does it has infinitely many zeros? No, it has only finite zeros in between them. So this option is also cancelled out. Right answers are only A and B are. There is one more method about that. There is one more method that we will see in the next example. Okay, now what is the tips for you? Whenever there is a system of this kind, and here A is a matrix, we always find the eigenvalue. What is the eigenvalue of this? You can see trace, determinant is minus 3 plus 4 is my 1. So what are the eigenvalues are there? 1 and 1. Clearly say that it has the repeated eigenvalue, satisfied. Li. So how you can check whether it's a vector or not? I can multiply this vector by 1 and minus 1. So what is the answer is 1, it's minus 1. Clearly say that eigenvalue is 1, eigenvector is this. This is also the correct answer. The general solution of this, now it has a 2 eigenvalue, 1 and 1. So how I can return that? Is a function of the t. So when you have the 2 equal roots, then we can see the eigenroots are my, then I can return the corresponding solution will be C1 e raised to power t, C2 e raised to power t times of t. That's my here. If you compare them, A, that is my constant is my A, this is my B. So you can see I can take A plus B of t e raised to power as a common. Now what is the x1 is 1 comma minus 1, and here that's also simpler. If I substitute here, if I just write x1 here, so it will be A minus A. If I write as a B, B of t and half of B minus B times of t into, so what is that? A plus bt minus A half B minus of, so what is the meaning of that? This is the constant, so that is a 1, bases are 1 and t. This is the constant, bases are 1 and t, multiplied by e raised to power t of this. What are the bases? T, e raised to power t. So bases are my here, which is the same of this. This is also the right answers. X1 and X2 are the linear independent. Can you multiply once they are written here? So all are my correct answers of these options. Again, this is the matrix A. What is the A is 2 cross two matrix such that the trace are my 0. So I can write the determinant equation is my trace of A plus of this. So what are these? Trace is my 0, determinant is positive. So I can say determinant is my say 1, which is a positive number. So what are the solutions? Plus minus iota. So solution is my C1 cos x plus C2 sin x. Now y of 0 is 0. So which one is a sin 0 is 0. So this is my y1, this is my y2. Then y1 and are they monotonically decreasing? No. Are they both increasing? No. Are both oscillating? Yes. Are constant? It's not be there. So the right answer is my C. Again, this is the matrix. You can write the eigenvalues. So clearly say that the eigenvalues are my diagonal mat because these are the upper and lower triangle. So eigenvalues are 0, 0 and 0. Once eigenvalues are 0, so you can see the roots are my 0. How you can write the equation? Constant t square. Fine. These are my bases of here, because once you have the roots, m is alpha, alpha and alpha, you can write as a e raised to power alpha, t e raised to power alpha, t square e raised to power alpha t. Here alpha is my 0. Now you can check that y1 basis 1 t square, 1 t square, half is a constant. You can write as a linear combination c1, c2, c3 of t square. So this is satisfied. 1 plus t is a linear combination of the 1 plus here this. So first option is correct. 1, this is also the linear, that's correct. This is also is a correct. Now we can see here e raised to power t. So I can open this 1 plus ta plus t square a square by 2 factorial and so on. Here the eigenvalue, the determinant of the eigenvalue is my 0. So it means a cube is my 0 because all has the, so I can see a cube has a 0. So up to this is the fine. Again you can see these are the linear combination of the 1 t square by 2, that's a constant. So this is because y0 is 1 1 1. So this is a linear combination of this basis. So we can see all are my correct options. Okay, again this is there, we can write the eigenvalue lambda square, sum 2, determinant will be plus 1. So what are the roots are there? Minus 1, minus 1. So what is the solution of this? How you can see, how you can write the solutions corresponding to them? You can write as a corresponding c1 e raised to power minus of t, c2 t times e raised to power minus of t. Now what is that? First one is a 0. Which one goes to the 0? Here. This is my y1, this is my y2, this is my y2, this is my y1. y1 and y2 both monotonically increasing. So if you take, how you can check the increasing or decreasing? We can take the derivative less than or greater than. What is the y2 dash? Which is a less than 0. It's a decreasing. So first option cancel, this option cancel out. Now what is the derivative of this? What is the first derivative of this? E raised to power here plus e raised to power this. So I can written as this 1 minus t. Now you can see these are the two cases. It is a greater than 0 when t is less than 1. It is less than 0 when t is greater than 1. Fine. Now then you can see this is the for all t. Now y1 and y2 both are monotonically decreasing. So this is my decreasing when t is greater than 1. But t is greater than 0, it's a decreasing, cancel out. This is a decreasing, y2 is decreasing, y1 is decreasing when t is greater than 1. So the right answer is 4th, that is the D is the right answer. Okay, now this is the eigenvalue problem. So this is a very simple problem. If you look about that eigenvalue, which things come in your mind when you look about this problem? That is nothing but my Sturm Liouville problem. So what is the Sturm Liouville problem? So if you remember that d by dx of px y dash minus qx y plus of rx of y is equal to 0. That's my differential equation. Now, and the conditions are my here, that is y at the initial point plus, say you can say alpha 1, alpha 2, y of dash of a 0, another one is beta 1 y at the another point, plus beta 2 y dash of b is equal to 0. Then if now what is the shortcut trick? If px, if qx, if rx all are my continuous. Second, if alpha 1, alpha 2, beta 1 and beta 2 all are my greater than equal to 0, then the eigenvalues are all positive. There is a simple shortcut tricks for you. You can check that. You can see, compare them. This is my 1, this is my 2, this is my 1. So this property is satisfied. Px 1 plus x4, qx 0. So 1 plus x4 is a continuous function. Q is my 0, r is my 1, all are my continuous. So eigenvalues are my all positive is my correct answer. Now there is another concept about the critical point. Whenever there is a critical point, you can consider the first function as a f, second function as a g. This is my f, this is my g. Then you can find the Jacobian matrix as partial derivative f of x, y, g of x, g of y, and then find the eigenvalues. So look at that. 2 minus 7, 3 minus 8. So if you find the eigenvalues, lambda square, trace, and it's a minus 16 plus 21, it's a 5. So what are the eigenvalues? Minus 5, minus 1. Fine. Now you can see the rule. If both the eigenvalues are my less than 0, then we will call as a node which is a asymptotically stable or a simple stable. Whenever eigenvalues are my both positive, then we will call as a node and it's called as the stable and as called as the unstable. Now we can see both the eigenvalues are less than 0. We call as the asymptotically stable node. Asymptotically stable spiral cancel out. Asymptotically stable node is the right answer of this problem. Again, the critical point, they are talking about the spiral. So we consider this as a f, this as a g. What is the partial derivative with respect to x at the point 0, 0? So 1 plus y square cos x. So y 0, 0 is part is 0. So answer is 1. Partial derivative with respect to y minus of 2 plus 2y sin x. Again this part at the point 0, 0 is 0. Partial derivative with respect to x is my 2. Partial derivative with respect to y minus 2. So it will be 2 cos y square and plus y sin y square of 2y minus. So at the point 0, 0, this part will be 0, this part will be 1. So it is my minus 5. So what are the eigenvalues? So it's trace plus 4 and determinant will be minus 5 plus 4. It's a minus 1. So what is the roots of this? You can't factor them. Minus 4 plus minus 16 plus 4. So clearly says minus 4. It's a 20. 2 root 5 by 2. So minus 2 plus minus root 5 over 1. So root 5 is 2 point something. So one eigenvalue is positive, second eigenvalue is negative. Remember, whenever there is a condition, now you can see when both are my same sign, then stable or unstable. When one eigenvalue is my greater than less than 0, other eigenvalue is my here, we call as the saddle point or called as the unstable saddle point. So this is called as the spiral is not be there, saddle point is. Fine. So these are the simple. When spiral means when it's a eigenvalues are in the complex number. When the eigenvalues are in the complex number, then it will be the spiral. Again, one more example are there, which is the f, g. Now write the matrix. Partial derivative with respect to x, 2x minus 2. Now at the point 2, it's minus of 2. Partial derivative with respect to y, 2y at the point is a 0. It's my 6x minus 1. Partial derivative with respect to here. So eigenvalues will be 1. Determinant is my minus of 6. Now what are those? So 1 plus minus b square plus 2ab over 2. So it is 1 plus minus 25 So 5 over 2. So 3 and 2 are the factors. So it's when you take a plus, so one is positive, other is negative. So it is called as the saddle point. So right answer is my C. One is the positive, other is negative, called as the saddle point. Okay, now next one is, which is 2020, which of the following is as polynomials. So look at that. What is the degree of 1? That is a plus bx. Degree of 2 is a plus bx plus cx square, and so on. So if you think about all these terms, if I firstly check what are the bases of this? 1x. What are the bases of this? 1x, x square, and so on. So let's firstly check x square. You can substitute here as a x square. It is my 2x square. What is the derivative of is a 2x? So 4x 1 plus x plus 2 times x plus 1 of x square. Is it 0? No. It is not equal to 0. So it means this cancel out. It also involve the x square. Cancel out. It also involve the x square. Cancel out. Right answer is here is the correct answer. You can see if I start from the x, what is the second derivative? 0. This is my 1, so it's a minus of 2, it's a plus of 2, it's a cancel out. Right answer is here. There is no need to check which one is the satisfied. You just check about the bases are. Okay, now look about this here. Fine. Which of the following? Y is increasing, decreasing. So what is the meaning of this line? What is the meaning of that? Y dash at the point 0 is 1. What is the meaning of that? 0 is my critical point and y dash is my greater than 0. What is the meaning of the y dash greater than 0? Y is my increasing. So once y is increasing, what is the meaning of that? Y goes to the infinity as x goes to the infinity. So the first part is satisfied. Similarly, this part is satisfied. Now whenever there is a condition of the infinitely many, so what is the tips for you? Remember, whenever this is my condition here, remember this is a very simple and the shortcut tips for you. You just remember this concept. Whenever there is a condition of y double dash here, then the first case, whenever q of x is my greater than 0, then it has infinite many zeros. Remember, zeros on the positive x-axis. Whenever q of x is less than 0, then it has the two conditions. Then it has the two conditions. The first one is it is monotonic function. It is either a monotonic function or it has at most 1 0. Remember, these are the two conditions on this q, provided y double dash plus qx is 0. So look at that. Now here we need a plus, it is a negative. What is a q? Q is a positive monotonically increasing. So it means q is my monotonically increasing, but minus of q is my less than 0. So it means these conditions are satisfied. So it has finitely many zeros? No. It has infinitely many zeros? No. So both options are cancelled out. It has at the most 1, but they are say finitely many, they are cancelled out. So this is the simple tips for you. You just remember that we can solve the many examples with the help of this problem. Okay, now look at this. More than one correct options are there. Which of the following is increasing, decreasing? So firstly, increasing are there. Okay, what is the meaning of the increasing? Y dash is greater than 0. Fine. What is the value of the y dash? 1 minus y square is greater than 0. So I can write an as y square minus 1 less than 0. We all knows what is the meaning of that. So we all knows whenever y minus alpha is less than 0, it means y belongs to the alpha and beta. So what is the meaning of that? It means y belongs to the minus 1 to plus 1. We start from the increasing, so it means y is increasing in the interval minus 1 to plus 1. Y is increasing in 0, 1, wrong. Y is increasing here is wrong. Now we can check about here. That's again a very simple. We can take the solutions. This is my dy of dx. You can integrate them. What is the integration of this? Half log of 1 plus y over 1 minus y is x plus c. So I can take as 1 plus y, 1 minus y is e raised to power x of c. I can see as a e log c are there. So or simple x into c. So how you can solve them? Can you find the value of y from here? So what is the value of the y from here? So I can take as a 2 are there. This 2 will be. So what is the value of y from here? Y will be my plus c. C you can easily find that. What is the y of 0 is 0. What is the c? Y of 0 is 0. Log 1 is 0. So c will be 0. So y will be my e raised to power 2x minus 1 e raised to power 2x plus 1. This is my solution. Now y of this is 1. When it will be 1? When it will be 2? That is not possible because this value is always less than 1. So I can clear this side here for you. So what is my y? E raised to power 2x minus 1 e raised to power 2x plus 1, which is always less than 1. Strictly less than 1. So the first option is cancelled out. Y of t is minus 1 for all the t. So how you can check that? Is for all the t. So if I simply take t as infinity, what will happen? What is the value of that t as infinity? So t as infinity, it goes to infinity by infinity. So if you take them, so it will goes to as a plus 1. It goes to 1, but it is not equality. If I take t as my minus of infinity, then this value will goes to my minus of 1. Fine. So what is the meaning of that? Y of t must be of greater than of minus 1. So lower limit will be minus 1. Upper limit is less than 1. Now is it y is increasing for in all the r? So we have seen y is minus 1 to 1 is increasing. That's very simple again. If I think about here, by taking x is my 1, what will happen? If I take x is my 0, so x is my 0, answer is my 0, e raised to power 0, 1, 1 minus 1, then e square minus 1 over e square minus 1, then e raised to power 4 minus 1 over e raised to power 4 plus 1, and we all know this is my here. So what is the meaning of that? It's my increasing. So once it's increasing and it's increasing for all the values of r is the right answer. So this is the right answers of the B and C. Okay, again that's a very simple. What is that? F is a Lipschitz continuous function. What is a continuous function you can take? I can simply take f is 0. So if f is 0, what is the meaning of that? Dy by dx is 0. So what is that? Y is equal to constant, and y of 1 is my 0. It means c is my 0. So what is the meaning of that? Y of x is my 0 for all the x in the domain. So clearly it says first option cancel because it says it only in the 0 or 1, but it is for all x. Is it y is bounded? Yes, because what is that? It's a constant function and it's a 0. Every 0 is a constant, is a bounded. Y is a strictly increasing function. You can see dy, what is the increasing function? Y dash must be greater than 0. But here you can see y dash is equal to 0. So it is not here. Dy by dx is unbounded. That's also a wrong option. Why? Because we see dy by dx is 0. But 0 is always be a bounded function. So it means this option is also cancelled. Right answer is only B of the part here. Okay, now this one is again the system of equation. That's again very simple. You can simply divide them. Dx over dy minus y over x. You can simplify them. X dy plus y dx is 0. You can integrate them. X square plus y square is over 2 constant. X0, Y0 is AB, so C will be my A square plus B square. Fine. So this option is correct one. This option is cancelled out because if I take A any greater than 0, if I say A is 1, B is my say 2, then this number will not goes to the infinity. So this option is cancelled out. This has a solution only when A, B are 0, cancel out. For any of the A and B are my correct options. So B and C are my correct answer. Okay, now this one, differential equation given to you, minimum, maximum. Okay, first one is the minimum. How you can find the minimum or maximum? you can find the y dash 0 and y double dash is either greater than 0 or less than 0. Here you can see that. What is the meaning of that? Y dash is my 0. What is the meaning of that? This 0 is my critical point. That's the meaning of this. So what is the meaning of that? Critical point at x is equal to 0. So it means here. Now at x is equal to 0, what is the value of this? Y dash minus y of 0 is e raised to power 0 is my 1. What is y of 0 is 0. So y double dash at the point 0 is my 1, which is greater than 0. So it has a minimum value. So first option is correct. Now you have to check whether the y is bounded or not. How you can do? We can simplify this. I can write for here. What is that? Auxiliary equation is m square minus 1. So m is 1 or minus 1. Solution is c1 e raised to power x, c2 e raised to power minus x. For the auxiliary, for the particular integral, I can write as a d square minus 1. I can multiply by x and differentiate, and I can take as of this. So it will be minus x by 2 e raised to power minus x. So what is the solution of this is c1 e raised to power x, c2 e raised to power minus x of here. Fine. Now you can see that limit e raised to power minus x of yx. If you take e raised to power minus x, that will be my c1 only. This will be my e raised to power minus of 2x. This will be e raised to power minus 2x. When x approaches infinity, this goes to the 0, this goes to the 0. That is only the c1. We will see what is the c1. When you take e raised to power x, it will be my e raised to power 2x. It is my c2. It is my only x. But when you take as x approaches infinity, this value will goes to the infinity. So its answer is cancel out. Y is bounded. You can see how you can check whether it's bounded or not. We can find the solution. How you can find the solution corresponding to them? You can check the, firstly you can find the y0. What is the y of 0? c1 plus c2 is a 0. What is the derivative at a point 0? c1 minus c2. What is the derivative of this case? So just wait. So when you take as a derivative, so what is the derivative of this at a point 0 is my half. So what is the solution of this? So clearly says that c1 is my 1 by 4, c2 is my minus 1 by 4. So it means when you take this, it's the correct option. Now the last option is how you can check whether it's bounded or not. That's again very simple. What is the meaning of the bounded? So if it's a c is a minus 1 by 4 minus x e raised to power minus x by 2. What is the meaning of the bounded? If I take x as infinity, if y goes to the finite, then it's a bounded. So what will happen when you take x as infinity or x as a minus infinity? So firstly we take x as infinity. This goes to the infinity. So it means y goes to infinity. It is not a bounded. So this option is also cancelled. So the right answers are A and C are my correct options. Okay, again this is a similar problem. So what is the shortcut tricks I told you earlier? Whenever x lies between 0 to L such that y of 0 is 0 and y of upper limit is 0, then the solution will be n square pi square by L square. Here L is my pi. So what is the value of the lambda in this case? It is nothing but my n square. So what is that? No value cancel out. Greater than equal to 0 cancel out because it also considered as a 3, but 3 can never be written as a n square. N is a natural number. So 1 I can written as a 1 square, n square. So both are my correct options. B and C are my correct options. Okay, look about this one. Which of the following form a basis? So what is the meaning of the basis? I think all of you know that it form a Li. Now, so which of the following form a basis? Li, another LD. So firstly we check whether it's LD or not. Can you write y1 as a linear combination of y2? You can never. Why? Because this number is non-zero. This is a 0. You can never multiply by any number so that it becomes a 0. So it means the first option is cancelled out. How you can check whether they are Li or LD? We all know if they have the distinct eigenvalue. If they have the distinct eigenvalue, then they have the n Li vectors. So we can find the determinant of this very simple. So it's a minus 5, it's my 24 plus 1, minus of 2, minus 6, minus 1, minus of 2, and 1, minus of 4. So it's a 25, it's a 125, it's a 7, it's a plus 14, it's a 3 plus 6, which is non-zero. Once determinant is non-zero, it means none of the eigenvalue is 0. It means it has the Li, or you can say it has a determinant is non-zero, it means it has a Li. So whatever the eigenvalues of this or the eigenvector, they are the Li's. So it has a 3 cross 3, so we will get as a 3 Li vectors, but it is given as a 2. So what you can see here, I can written this vector as e raised to power minus 3 is outside 1 1 0. Fine. So this means minus 3 is eigenvalue. Similarly for here, y1 and y2 form a basis, that's 2, because if you multiply, what is the basis? That's Li. If you multiply this by 2 vector, and you can easily see that alpha 1 both alpha 2 0, because in the first case alpha 1 must be 0, and for the second last case alpha 2 must be 0. So it is here. Y1 and y2 are Li, that's correct again, but do not form a basis for the set of this, but do not form a basis. Sorry, for the basis it must have a Li, but it is not be there. So this form a Li but not a basis. There exists a y3, yes, true, so that it form a basis corresponding to the third eigenvalue. So it will be here. Okay, next one is the Wronskian. Okay, what is the concept is, if Wronskian is 0, we call as the LD. If Wronskian is non-zero, we call as the Li. Moreover, if Wronskian is 0, if I say domain is my here, if I take any of the points C in between them, if I prove that the Wronskian of C is 0 in between, then the Wronskian of is 0 also for all the x in the AB. Fine, this is the property of the Wronskian. Now you can see here, what is the Wronskian, how you can define the Wronskian, u1, u2, and here. Now add the point x is equal to 0. What is the meaning of the x 0? So this value will be 0, this is 0, whatever the non-zero values or the 0 value, Wronskian is a 0. And you can see 0 belongs to the minus 1 to plus 1. So what is the meaning of that? 0 belongs to this, it means Wronskian is 0 for all the x lies in between them. So what is the meaning of that? Once is a 0, it's a LD. So Wronskian is a non-zero for all x, cancel out, is the correct option. Once the Wronskian is 0, it is a LD. So B and C are my correct options. Okay, which of the following is a that's a very simple. I think f is an even, y is an odd. So what is the meaning of that? This part, f is an even. Whatever the odd function, if you apply on the even side, what will be the result? It is always be the even. Fine. So it means the left hand side must be a even, then only the equality will be hold. So when it can be even, so even means always a positive sign. So which of the following gives the derivative as a positive sign? So you can see, if you take the derivative of this, it will give you here, and minus minus plus, so it give you positive sign. The right answer is here. Look at that. If you take the derivative of this, so what will happen is y dash, if you take the minus, is a negative. So once is a negative, it can never be a even function. So it means this option cancel, again this cancel, because of this negative again a cancel. Right answer is my A. Okay, again you can see I can return this problem as of this. What is that? This is again of this kind. Lambda y is 0, y of 0 is 0, y of pi is equal to 0. Then the solution will be n square pi square by L square. If I say this is my L, and the solution will be a sine n pi over Lx. So here L is my 1. Okay, but lambda is already given to you as a pi. So what is the meaning of that? N is 1 in this case, L is my 1, because here. So if I substitute here, this is my A sine pi x. Fine, that is so u is equal to A sine pi x. Now we can substitute here. What is the first option? What is the first derivative of this? A sine, pi A cos pi x. So if I substitute squaring, so A square pi square cos square plus pi square u square, that is my A square sine square pi x. So sine square plus cos square is 1, so answer is A square pi square. What is the right hand side is u dash, this is here derivative at the point 0, cos 0 is my 1, so answer is pi square A square. Both are correct option here. Once this is correct, so this option is cancelled out. Look at the third option, second and the fourth option, either one of them is the correct. So look at this one option. Integration u dash square, so it is my A square pi square cos square of pi x minus pi square 0 to 1 u square A square sine square of pi x. Fine. Now what is that? A square pi square will be common. Cos square, what is the answer of this? Cos square x minus sine square of pi x. So clearly says that when you integrate them, it gives you a 0. A square pi square as a 0. So this option is correct. This option is cancelled. Or you can simplify that. That's very simple. Okay. So phi is given to you as x1, y2, x2, y1. You have to find the derivative. That's very simple, I think. x1, y2 dash, x1, y2, x2, y2 dash, x2 dash, y1. Okay. And these are my solutions. What is the meaning of this solution? It means x1 dash minus x1 plus t times y1. From here, these are the second solutions. So y2 dash t times y2 minus y2. Fine. Now you can find that. You can substitute the x1 dash here. So x1, if you multiply them y2, it will be minus x1 y2 plus t times y1 y2. I can substitute y2 dash here. And you can simplify that. That's very simple. You can simplify them. You will get as in terms of x1 y2. You can see x1 y2 and x2 y1. Rest all will be cancelled out. You will get the right answer as A is the simplified answer. Okay. What is that? This is my Cauchy-Euler equation. Fine. So what is the Cauchy-Euler equation is? In journal it is here plus pxy plus qy is equal to 0. Then you can find the auxiliary equation as p minus 1 m plus q is equal to 0. So what are the solutions? P is my minus of 2, it's minus of 3, q is my plus of 2. So the solution will be 2 and 1. So once is a Cauchy-Euler, the solution will be C1 x raised to power 2, C2 x raised to power 1. Now you can substitute here. What is the y1? C1 plus C2. What is the derivative is? 2C1 plus C2 is my 1. Y2 4C1 2C2 plus 4C1 because the derivative at the point 2 and at the point 2 is 0. Now it has a unique solution. So I can write this in terms of the matrix C1 C2. What is the coefficient of this? 1 plus 2 alpha and 1 plus alpha. 4 plus 4 beta and 2 plus beta. Fine. So when it has a unique solution, when the determinant of A is non-zero, this is my A. So that's very simple. If I take alpha as a minus 1, beta as a 2, so what is the matrix? So first matrix will be when it is minus 1, 0, beta is my 2, so 8, 12, and this is my 4. Clearly say that determinant is a non-zero, so it's a right answer. Minus 1, minus 2. 1, it's a minus 1, so it's a minus 1, it will be my minus 1 here. When beta is minus of 2, is a 0. clearly say that the rank of this determinant is a 0, so it means this is not the right answer. Minus 2, 2. When alpha is minus of 2, it's a minus 3. It's my minus of 2. When beta is my 2 here, and this is my 4. So it's a minus 1. So clearly say that again the determinant will be a 0. So this is not the right answer. Because it's only the part B, only the one correct options are there. When you take alpha as a minus 3, so it's a minus 5. It's a minus of 2. Beta is 2 by 3. So it's 4 plus 8 by 3, 12, 20 by 3. And it is 6, 8 by 3. So 40 plus 40, 0. So the right answer is only A is the correct answer. Okay, which of the following is a non-solution are here? We have to find the solution of this. You can see what is the value of the t. T can be any value. So I can simply take as 0. If I simply take t as a 0, what is the meaning of this? E raised to power 0, 1. Here, so what is the solution of this? C1 cos x, C2 sin x. When you take x0 is equal to 0, C1 will be 0. So the solution will be C2 sin x. Fine. How many zeros are there? Infinitely many zeros. So is equal to 1 cancel, is equal to 2, greater than or equal to 3, greater than or equal to here. So B and D are my correct answer. Now again this is a system. So I can write it as a matrix. That is x, y, x, y. Now we can find the eigenvalue. Eigenvalues are minus 1 and minus 1. Then you can write the solution corresponding to this is e raised to power minus of t, and second is t e raised to power minus t. So what is that? If I write as t, if I simplify c1 e raised to power minus t plus c2 e raised to power here. If I take c1 and c2 as both 1, it give you this answer. Fine. It also give you this answer because if I just simply take this as my y of t, then what is the meaning of this? T times y of t, and c1 and c2 as my 1 is also the correct answer. These two options are cancelled. Okay, singular point. That's a very simple. We all know this p x dash plus qx is equal to 0 is a singular point when you take has a singular point x is equal to a. When you take limit as x approaches this of p and q will goes to the infinite, then we equalize here. So what is my p? X over x minus 1, q is 1 over x. So clearly says that x is equal to 1, this goes to the infinity, this goes to the infinity. It's a singular point. 0, this goes to the infinity. So both p and q are my singular points. Again, that's a very simple because it's a simple derivative. I can written as a matrix 1, 0, minus 1. What are eigenvalues? Eigenvalues are 1 and minus 1. So we can written as a t, sorry, they are the distinct here and this. So we can see what are, these are space. So what is the meaning of the spaces? You have to find the eigenvectors. You have to find the eigenvectors. But anyhow, how you can do that? So you can see 0, how you can find the eigenvectors. So a minus lambda I. So corresponding to lambda is equal to 1. What are the eigenvalues? You can see once you find the eigenvector corresponding to this here. So when lambda is equal to 1, it's a 0, 1, 0, minus of 2. So x1, x2 is 0, 0. What are the eigenvectors corresponding to this? So clearly says it give you x2 as a 0. So eigenvector is my 1, 0. When lambda is equal to minus 1, it will be my 2, 1, 0, 0. So it will give you x1, x2 is 0. So x2 is my minus. So eigenvector will be my 1 and minus 2. Fine. So what is the final answer of this problem? You can write this solution as, so the solution will be, how you can write the solution? Constant e raised to power this into eigenvector 1, 0, c2 e raised to power minus of this, eigenvector is my here. Now you can check your answers. 0 and minus, so this part can never be a 0. So first part is cancel out. E raised to power t 0, this also cancel out. No, sorry, e raised to power t 0, fine. How you can write this? E raised to power t, e raised to power minus t over 2. So if I separate them, if I separate them, it will be e raised to power this, e raised to power here, and of this. So if this will be half comma 0, but we need only 1, so this option is cancel out. This is 1 comma minus 2, that's satisfied. How I write the sign? E raised to power t here, and this is e raised to power minus t. So if I take as a half comma 0, that's also satisfied. Minus half and 1, that's also satisfied here. Minus half and 1, same thing. So this is the correct option. Again, this is the same as option here. So 3 and 4 are the correct options. Okay, that's also very simple. I can written this part as 2 sine, I can multiply by cos minus cos y is equal to cos x of y 0. Fine. So how you can do that? That's very simple. I can written this part as of this minus. Fine. Now how you can do that? You can integrate on the both side. Minus y sin x is equal to c. Now it's a linear equation. Y dash minus tan xy is equal to c secant x. Or you can also see that from here you can again written as y cos x c. So the solution will be y cos x c1x plus c2, or you can written as c1x plus c2 of secant x. Now you can see here there are the two y1 and y2 such that these are there. That's correct. So I can written as a c1x plus c2 secant x, c1x plus COD I call as AB, I call as a C and D of secant x. This is my y1, this is my y2. If you divide them, secant will be cancelled, cross multiply, you will get the here. Y double dash, take this value at x is equal to 0. So y double dash 0, tan 0 is 0, y of 0 is 0. So that's satisfied. This part, y of 0 is 1. So this is my solution. Now this is my solution. Y is c1x plus c2 of secant x. Now you can see firstly y of pi, okay, firstly c1 and c2. So y of 0 is 1, secant 0 is 1, this is 0, so c2 is my 1. Y dash of 0 is my 1. So what is the y dash of 0? I think that's a very simple. So what is the y dash? So this is my 1. So if you multiply them, it is my c1 secant x and c1x plus 1 secant x tan x. So this part will be 0 at x is equal to 0. Secant 0 is 1. So this part is my 1. So c1 is also be a 1. So my solution will be x plus 1 secant x. Now you can check that pi by 3. So it's a pi by 3 plus 1. Secant pi by 3 is 2. That's my correct answers. And if this is minus 1, what will happen if this is minus 1? C1 will be minus 1. So this option is wrong option. So the right y dash 0, this is there, y dash 0 is minus 1. So C1 will be minus 1. So it will be minus of here. So that's also correct option. In that case C1 is minus 1. So solution will be here. So what is the C of minus pi by 3? It's again a plus pi by 3. So all options are my correct answers. That's a similar question about that. The solution will be n square pi square. L is my 1. So this always be the positive roots are there. When they are the strictly positive, so by using the orthogonal property, they are the orthogonal. That's a very straightforward task. Again a simple Wronskian are there. Wronskian is 0, LD, non-zero, Li. So if they are Li, Wronskian is non-zero. LD, cancel, independent cancel, cancel. The right answer is only D is the right answer. Okay, now there is a question of the non-homogeneous are there. We all know when there is a homogeneous differential equation, y1 and y2 are solution, then c1 y1 c2 y2 is also the solution. But whenever there is a non-homogeneous solution, then c1 y1 c2 y2 are solution only when the coefficient of the ci is 1. That's a simple tips for you. So you just check that whether this plus this is a 0 or not. Is a 1. Satisfied? y3 y2 cancel out, but they are not cancel. It's not be 1. It's here. This is a 0, but we need a 1. So this is not cancel out. It's a 1. y3 cancel out, y1 not cancel out, so it is not be there. So the right answer is only first option. Okay, the method of the variation of parameters. Okay, so y double dash py dash qy is r. So how you can find the solution of this? c1 y1 c2 y2 plus y of p. So that's my right answer of this. Wronskian always be a non-zero. What is the v1 and v2? They are any of the function but may or may not be a differentiable. So this option cancel. These are the right answers. So next one is here. Again, this is a very simple as I discussed for the previous solution. If this is a case, then if this value is my greater than 0 and if this value is greater than 0, then it has my infinitely many zeros, because the option has infinitely many zeros as well. So what is the qx? If you compare them, this is my, so we can see number of here. So this is my here. Clearly sees I can return this number as 3x square over 1 plus x square. This number is always be positive when x is greater than 0. So this number is always be greater than 1 or greater than 0. So it has infinitely many zeros over the positive x-axis. So this is my positive x-axis because this is the closed interval here. This is the first option for you. Now the second point, now you can see the second option is whether it has at least or at most. Now second tips for you, whenever we are talking about the non-trivial solutions, then it has at most a finite number of the zeros. It has a finite number of the zeros on the closed interval a comma b. Now what you can do, these are closed intervals. If I see here, if my talking about this, if I just simply take as my here, clearly say that this differential equation can easily solve the problem. If I take the two problem in such a way that q of x is my greater than of the px, then the number of the zeros on here depending upon the roots of the px. So what you can do, if I simply take of this, that is p of x is my 1 and q of x is greater than 1, so that means this property is satisfied. So what is the solution of this? At the condition y of 0. So clearly says this is my c sine of x. Fine. Now what is that? This has the infinitely many zeros and it has at least 2 zeros. When you take n is 1, it has 0 pi. So when you take as a 0 and pi, the roots are my here. So there is in between this value, this is the solutions of the p. So we can find the solutions of the q. There is a 1 0 of pi by 2 such that there is at least 1 0. Similarly for here, when you take as a 0, n is my 1, it is a 0 to pi, and here you will get as most, at most, we can get as also there. So B, C, D are my correct answers. Okay, what is a closed path solutions? If I consider this as f, this as a g, you can simply take g upon y if it is greater than 0, or you can say it is not 0 for all the domain, then it means no closed path. That's a simple tips for you. So you can find the partial derivative with respect to x. 12x square, 5x4, y4. This with respect to y, 5x4 and 6x square, y square. So if you cancel them, 18x square, y square, which is always be a greater than 0. That's same sign because of positive, so it means there is a no closed solution. Okay, which is the largest possible value of the x1? That's a very simple. So this value I can consider f of here. What is the f of this is? I can simply take as, because this is the upper bound, I can take as equality. So what is that? X dash. What is the f of this? 4 times. Fine. Now you can integrate them. What is that? This is log of x is my 4 plus c, or 4 of t plus c. So x is my c e raised to power 4t. X of 0 is c, 3. So 3c. So c is my 3. So what is the x of t is 3 e raised to power is the right answer. And you get the largest value at the 1. So 3 e raised to power 4 is the right answer. Okay, uniqueness, bounded and so on. That's again very simple. You can use the Picard's results. What is that? We all know whenever y minus 1 is this, then the problem this here, what is that? This has a unique solution over the domain x is less than equal to h, where h is minimum of a and b upon m. What is my m? M will be my maximum of fxy. What is the fxy? X square plus y square. So what is the mode of xy square is? Mode x square plus mode y square. So what is the mode of this? Its upper value is my 1. So it is my 1. Y is my upper value is b plus 1 whole square. Fine. So what is that? A is my 1. So h is my minimum of 1. B over 1 plus b plus 1 whole square. Now clearly says this number is less than 1. So the answer is less than 1. So it means mode of x is less than 1 is the right answer. So clearly says what is the pi by 4? Pi by 4 is 3.14 divided by 4. It's a 0 point something which is less than 1. So it has a unique solution. According to the Picards, this also has a bounded solution. What is the meaning of singularity? It means we can get a one value of the y at some x, it goes to the infinity. That's very simple. Now here you can see this value is strictly less than 1. So the uniqueness solution exists as strictly less than 1. I can simply take boundary point. X is 1. So what is the my here? This is 1 plus y square. Now if you integrate them, it is my tan inverse y is x plus c. So y is my tan of x plus c. Fine. Now we all know, now my target is y at infinity. So we all know pi by 2 goes to the infinity. Pi by 2 is means 1.57 goes to the infinity. At x is 1. What is that? 1 plus c. So if I simply say c is my 0.57. So what is that? It is a tan pi. It goes to the infinity. So which lies between here. So it means there is a singularity lies here. Also y is unbounded because 1.57 lies in between them, and tan pi by 4 is infinity, which is a unbounded also. That's again a very simple. You can find the eigenvalues of this, minus of this, and plus it's a plus and it's a minus 2 and minus of 6. So minus 3 and plus 2 are my eigenvalues. So c1 e raised to power minus and c2 e raised to power plus of this. How you can find the value of the h? Y dash minus of ay. So since it is a polynomial, so I can consider this as here. What is that? I can consider y as ax plus b and cx plus d, or ct of this. So what is the y dash? A, C. A is my 1, 4, minus 2, 1 is AT plus B, CT plus D. Now equate the coefficient. I can equate firstly coefficient of the T. There is nothing here there. This is A minus C. Fine. Second part is this is A, this is C. Then another part is from the below 4A minus 4A plus of 2C. Now if you solve them, if I multiply by 2 and add them, it's a 6, 8. It's a 6 of A. So A is my minus 4 by 3. If I substitute A is minus 4 by 3 here, so C will be, so 3 plus 4 by 3. C minus 4, 9, 5 by 3. Okay. Now whatever the value of the B and D, look at that. My target is to find the infinity. So what is my solution? This plus AT plus B and CT plus D. Now if you look about that, there is no need to solve the problem. If I just write for you here, what is that? If you divide it by T, this is by T and this is by T, and T approaches infinity, this goes to the 0, this must goes to the 0, it means C2 must be 0, this will be goes to the only A and C, because B by T is a 0. So what is the answer of this? Minus 4 by 3 plus 5 by 3, minus 4 by 3 plus 5 by 3. So this is the possible answer of this one, because it is only plus minus sign is changed. Rest are otherwise none of these the correct answer. But if you look about the more closer answer, that is the correct answer of this. Again, this is the same problem. Whenever this is the solution, then your solution will be n square pi square upon L square. Here this is my L, so when you substitute here, lambda will be my n square. So this and these are my correct options. So this is the way you can solve all these questions are. Last question, I can return this number as coefficient. Firstly this. So what is that? This is my Bernoulli equation. So once you have the Bernoulli equation, you can transform them into the linear equation. The simplest way is you can write as say dt by d of any another variable, say x plus 1 minus n, p of x is q, or okay, that's quite lengthy. You can see what you can do. I can divide it by root y on the both side is t square over t. Fine. Now I can divide it by t here. So what you can do, I can take this number as say z. So 1 by 2 minus 1 by 2 y raised to power minus 3 by 2 dy by this is here. So once you substitute here, you can find the integrating factor also by using this here. So I think that's very simple. You can try to yourself, because already a video is very lengthy. You can try to solve this. Once you will solve in this case, you will get the solution as of here. That's a very simple, that's a Bernoulli equation. You can solve the Bernoulli equation very simple manner. You will get as the solution. So what is the y of 2? That is my 16 is the right answer of this problem. So that's a very simple shortcut tricks are there. We will see the next lecture on the June 2011 to 23. I hope you can simply like, share and comment on my videos. Best of luck students. Happy learning.